Hello, everyone, and welcome to another episode of Alexa and Friends. My name is Jeff Blankenberg, and today I get the opportunity to chat with Yang Liu, who's a principal scientist on the Alexa AI team. So every once in a while, we get some great guests from our Amazon Science organization, and today is
this might answer your question.
Oh boy, Alexa. And today is no exception. I am so excited to have you here, Yang. Thank you so much for joining.
Thank you, Jeff. Good morning or good afternoon.
So one of the things that I like to do, and I know you've been warned about this, is that I like to ask a few silly questions at the beginning of these interviews to give people a little idea about who you are and maybe some perspectives you have on things. So the first question that I like to ask, and for anyone that may watch future episodes of this, I do have intentions to switch this up and change the questions. But for today, these might seem familiar. So the first question is, we've had lots and lots of superhero movies, and comic book characters are very, very popular these days. So I'm curious, if you could pick a superhero power for yourself, what do you think you might pick?
Actually, I was walking while watching some of your episodes before, and I was thinking, when my kids sometimes play this, well, you can have a wish, and what's your wish with the game? And one of them often said, can I wish for more wishes? So my first reaction is, can I use my superpower to have more superpowers, whatever, super strength, or supervision, those kinds of things. But that's just joking. I know I can only have one. And if I can be greedy, maybe two for now. The first one, I really hope I can have the superpower to stop the pandemic right now. And maybe that's one for everybody, not just for me. And the other one is the real one. That's probably more related to what we're going to talk about today. I often hope I can have a superpower to kind of formulate more my thoughts into a good language, a good way to express to different audience. Like when I was talking to you about some technical stuff, that's probably a different way from talking to my colleague about the same content. And same thing when I was talking to my kids, sometimes I hope, I should use the language that's good for them. So like formulating those random thoughts or talking points into what good way. That's
interesting.
That's what
I like that. The way that occurs to me is it feels like language-based empathy. Right, you're able to recognize and identify the best way to explain something or communicate with someone, and then be naturally able to do that in whatever words or language, even potentially, that would best be suited for. I love that. That's I like that, and so that's an easy one to talk about how you would use it for good. That's something else that I like to focus on with these superpower questions. Most superpowers, somebody wants to have super strength or speed or flight or something.
That's very natural.
It's very easy to understand how you might use those for evil, but I always like to ask how you use it for good. But this one's pretty clear.
This one, I guess,
share your knowledge
for evil, or even factually incorrect the information, and then you will not do any good, right? Whether you can use this kind of thing. Maybe we'll talk more about this when you talk about these chatbots and over the language generation techniques later.
Yeah. Agreed, man. This is a good one. I really like that. All right, my second question. I have to tell you a little story first, and then I need you to make a choice. So, I want you to imagine you're walking through a large city, and you need to get one block over. And one large city block can take a while to walk all the way around. And so you note on your way that there's an alley that leads directly where you'd like to go. It's a bright, sunny day. There's nothing to suggest that there would be any trouble going down this alley. So you walk down the alley towards your destination. And as you get about halfway down, you notice that a large horse-sized chicken, horse-sized duck, I'm sorry, why did I say chicken? Horse-sized duck emerges at the end that you're heading towards. It's a very, very large duck, about the size of a horse. And as would be natural, you say, I'm not going that way. That looks insane. I'm going to turn around and go the other way, take the longer route, only to find out that end has been closed by 100 duck-sized horses, tiny horses. Now, you're probably going to be in some sort of scuffle or fight as you go through this, but I'd love to know which direction you would go and why you think you might have a better success going that direction.
do they look cute or aggressive? Well, I guess
They're
it
they're more on
depends.
the aggressive side than they are on the cute.
Okay, yeah, yeah. Then that's different from what playing with cute animals. I don't know. I guess my decision probably will be based on my instinct at that particular moment. But now, if I can do more logical thinking, I think I will go with the one horse-sized dog.
Right.
It just feels whether you have 100 duck-sized horses, they form, they can join forces, they form like an army, then it's kind of hard to fight with those. So I'll go with one, and the horse size seems doable, manageable.
I have to say, I've asked this question of more than 24 people at this point, and you were the first person to suggest that the small horses could team up, like would like fight in unison, right? Where they're actually working together.
Yeah.
First person to suggest that. And I think you're right. I think that like if we have a world where there are tiny horses, what's to say that they couldn't also be communicating and form an attack?
Yeah, definitely.
Brilliant.
But they will use their language. Maybe I can express my thought. Let me go through, and then they will hear what in their language, and then they can let me do that.
Yeah. And it's nice that you brought your superpower into this, because it doesn't just apply to humans. It would be nice to be able to tell my dog exactly what I need her to do.
Yeah.
Get her to contribute around the house a little bit instead of just leaving her toys everywhere, right? That would be great. All right. Well, that was fantastic. Thanks for the fun there at the beginning. The next thing that I like to do, and this is one of our audience's favorite parts, is to kind of understand where you came from and how you got to where you are today. So I mentioned that you're a principal scientist on the Alexa AI team, and we'll get into that more a bit later. But what I'd like to know initially is kind of what your origin story is, to go back to the superhero kind of stories. Where did you come from? Where did you go to school? Where did you grow up? I'd love the long version of kind of where you started and how you got to where you are today.
Yeah, we can do the long version.
All right.
Yeah, a lot of things, when now looking back, it seems they happen naturally. What I didn't do very deliberative thinking decision, but we can go through the story. Maybe they are not so interesting. So I grew up in China, and then went to Tsinghua University in Beijing. Back then, when you went to university, then you need to choose a major. Well, same thing now, you still need to choose a major. So I majored in electrical engineering. That's kind of my parents' decision. And I still remember when I was deciding, should I do computer science, should I do electrical engineering, or even medical or lawyer, all those things. Between electrical engineering and computer science, my dad felt you don't really want to major in computer science. Computer is just a tool you use in your whatever work, but you don't do it for a career. So he thought I should major in electrical engineering. You do circuit, signal, those kinds of things, and you can still use computer. Now it might be the other way around. People choose computer science, and then they learn all these computer skills, and then they can go to different industry, because everywhere you need computer, you need software, or any kind of thing.
That's something I say frequently, is that I have a daughter that's 17. She's looking to enter college here soon. And I told her, there will never be a shortage of software developers.
Right. Yeah. So it's different. But back then, as I said, my dad thought, you shouldn't just work on computer. Well, the computer is just the assistant or tool you use. So I went to Tsinghua, and I studied in electrical engineering. And then in that department, we have over 200 students, and the school, they kind of assign you to different classes. You have 30, 40-ish students in one class. And then all of these classes, they have different focused areas. One class is more about signal processing, and the other one is more about circuit, the other one microwave or image, all those different focused subfields or areas. And then for my class with assignment, kind of. Most of the professors we work with, they worked on signal processing, pattern recognition, communication. So that's kind of how I started with this area. And then in the final year, we needed to do an undergraduate thesis. And because of that class I was in, I started working with professors in recognition lab. The undergraduate thesis topic for me was Chinese word segmentation. I don't know if you know the language or Chinese. We write without any space. It's just a sequence of characters. And then if you want to do any kind of language processing or even speech recognition, you need to have this unit like word. In English, you have space. That's a very good delimiter. You can get the words. When in Chinese, it's just a sequence of characters. You have these 10, 20 characters. You need to find the words. So say, for example, you have character A, B, C, D. You may segment it into A, B followed by C, D, 2 words, or it may be A, B, C as a word, and then D as another word. So that's my thesis for the topic. It's still language processing task right now. Back then, the approach we used is, let's do a dictionary-based approach, and we will look up what in the dictionary and see, do I see word ABC or do I see the word AB? And then you can use a greedy approach. You can go with the longest word you can find. ABC is the longest, let's do that one. And then if D is not a word, you can go back and you can change your decision. Let's do AB followed by CD. So that's a very simple approach. Then we also added like a probability, what makes the most sense, and what's a reasonable segmentation for that context. Anyway, so that's how I started. I started doing this kind of language processing. And then the model we used, once you get the words out, you can train this thing called language model. A language model tells you the probability of a word following some history or following, and that's in speech recognition. So after I finished my undergraduate thesis, and as I said, everything just happened naturally because we all kind of had good grades, and then you just naturally continued with master degree. So I continued in that same speech recognition lab, and I was working on all these speech recognition and language modeling problem. Everything was for speech recognition. And I still remember when we were doing master research or thesis, and we worked with this company, Philips. Right now it's a very different company or different word, but that's for building a large vocabulary speech recognition system. And often the time we just sit in front of the computer and you say something that's very long and you look at the transcription if the computer is recognizing it correctly. I still remember all those demos. That vision image is still here. Yeah, so that's undergraduate and the master. I worked on all these speech recognition, language processing problems. And then after I got my master, again, it's just a natural decision. Everyone came to US to pursue for even advanced degree. So I came to US for PhD. And then for my PhD dissertation, I worked in this place called International Computer Science Institute, ICSE, in Berkeley. The topic is supported by DARPA project, and the program was called EARS. This is for something called a rich transcription of speech. So you probably know in speech recognition, you have the audio, you have the speech, and you need to get the words out. This is speech recognition. But for that program, in addition to getting the correct words, we want to generate the so-called rich information. You need to know who is talking. This is speaker A says something, this is speaker B who said something else. And we also want to find a sentence boundary. When you talk, you don't say period, comma, exclamation mark. Everything is kind of hidden, implicit. But for downstream components to understand the speech recognition out of it, it's better to have like punctuation. If things looks like a written language, it's much easier. So we worked on these problems, identifying sentence boundary and also disfluencies. In spontaneous speech, people repeat themselves, people correct themselves, people say these, I know you, but you know, like what I'm doing right now. So we want to find all of these things and clean it up, and everything will be easy for the subsequent language processing component. And this is called rich transcription. So that's my thesis topic.
Sorry to interrupt. Does rich transcription also include things like sentiment analysis and emotion detection?
Not really. Well, that's still focusing on just the surface form, getting the speech and putting punctuation, get the additional like disfluencies I mentioned, and the speaker information. So that was what the program was about.
Got it. Because I know we have things specifically with Alexa that offer, for example, speaker recognition, right? Who is the person talking? Was any of your research part of where I know that was early on in your PhD years, but was any of that a basis for some of the work that we've done to enable things?
I think so. Well, that's not my work, but we had colleagues who also worked in this DARPA EARS program, and that problem you mentioned, the speaker recognition, it's called the speaker diarization. When you have a multi-party meeting, then you need to know who spoke when. And the approach they developed right now is already 17 years ago. It was the basis for a lot of the things we are using now, not just we, and also the entire community. And one of my kind of a mentor or co-advisors for my PhD thesis back then in Berkeley ICSE, his name is Andres Stokoe, and right now he also works at Alexa, and he is doing all these with speech recognition, speaker diarization problem.
Very, very cool. And so you've obviously had a rich history in voice and speech. How long have you been at Amazon at Alexa?
2 years. So we can continue that rundown. After I got my PhD, and again, I just feel it's natural. I want to continue with the research, and I just started my academic career. I went to the University of Texas at Dallas as a faculty member. So I supervised the students there, and we worked on a variety of speech and language related problems, like speech recognition, modeling, prosody. Prosody means how you talk, not just what you say, how you say things.
Right.
And then like summarization, sentiment analysis, you mentioned a variety of problems, and we probably can touch on some of those problems later.
Yeah.
So that's the kind of being in academia, working with students and postdoc, and working on all of these kind of scientifically interesting problems. And then after many years being there, because kind of family reasons, I moved to California, and I switched from academia to industry. And being in the industry, I started seeing the other side of research. It's not just for the sake of doing research or even publication. It's mostly for products, and you want to develop things, and that will be used by millions, billions of users. So
right.
that's another interesting aspect of all of these speech and language technology. And I worked on different problems in a couple of different companies. And as you said, I joined Amazon almost 2 years ago.
Yeah, and you're being modest about those other companies you've worked for, right? I mean, you've done time at Google, you've done time at Facebook.
Yeah.
I mean, I think those kinds of things are really interesting to share, because it shows that the scientific community is a big part of a lot of the work that all of us are involved with and doing. And I would imagine as a researcher, it's got to be really interesting to be able to take the work that you've done, the research that you've done, and now figure out ways to scale that to millions and billions of people. Because that's a whole different animal than just a small subset of 1,000 or 100,000.
Yeah. So that the horse size or duck size thing, whether may be applicable here. Yeah, when you try to scale things that can be used by all of these millions, billions of users, and also with some latency constraint, it's a very different problem from writing papers. I just get 10% improvement in some accuracy, and that. You mentioned about the different companies. So when I was at Facebook and we were working on these natural language processing problems, originally, like when, I don't know if you use Facebook, but when you see those recommended posts, often the time they use a lot of like social network information. Your friends would have already seen this, and you probably can look at this post or what are some videos, but our focus was trying to look at the content of that post. Is this more interesting and relevant to your interest? So we were doing some language processing, finding entities, and see if this is something that's interesting to that user based on his profile, what interests, and the past browsing history. So that's a good use of all these like NLP techniques.
And you just have an incredible history. This is 25 years of speech and language. It's amazing.
Yeah.
So congratulations on that. And speaking of congratulations, I heard that you were recently named on the International Speech Communication Association, ISCA, for 2021. That's amazing.
Yeah, I guess I can only say I'm humbled. I'm honored to get that recognition. So ISCA, well, that's Community for Speech Communication, International Speech Communication Association, and they do all kinds of research related to speech communication, and that covers phonetics, like phonemes or the sounds, these kinds of things, and also linguistic information about the language itself. Of course, the main part is about computers. Well, if you want to develop all these systems that need to recognize speech, understand speech, and recognize the speaker. So all these things are covered in this community. And there are also other aspects related to even like medical, hearing aids, and speech language pathology disorders. All of those things are part of the research topics in ISCA. And similar to many other scientific communities, they have this fellow program that kind of recognize people who have contributed significantly to the community. And every year they recognize a different number of people. This year, I remember, I think it's 8 people that were selected to be fellow of ISCA. And for me, my contribution is similar to what I was telling you, what I've been doing, speech recognition, understanding, prosody modeling, summarization, NLP research in general.
Right. And calling back to your college degree, the degree your dad recommended you get, electrical engineering, this isn't your first kind of recognition either, right? I mean, you're also a fellow in the IEEE?
Yeah, that happened, I guess, several months before. And if I may, I don't know, I doubt whether anyone I know is in the audience right now. I really want to express my gratitude to all of the people I've worked with, starting with those people who introduced me to the field, like the people I worked with when I was undergraduate students, or professors in that speech recognition lab, and then all the way in the past 20, 25 years, all my advisors, mentors, students, postdocs, and colleagues, even family and friends. It's like Oscar's speech. I have that feeling now. And then related to these fellows, I think I often have this what is called imposter syndrome. And that also maybe because I'm one of those minorities, female, and this is a problem people talk a lot recently. And you said that you have a daughter. I'm hoping when the next generation, when people look at these different science community, then look at all the fellows or other people they list on the website, and they will see people who are like them, and they will have less and less the feeling I have. I hope that's going to be a good thing for the community.
I know it's rampant in the technology and science communities, the idea of imposter syndrome. I think it's good. While I don't enjoy the feeling that I get, I think it's a healthy perspective, because the opposite, I've actually given talks on this, is something called Dunning-Kruger syndrome. Have you heard of that?
Not really. I guess I don't have that.
Sure, no, you don't at all. Those are the people that believe that they are amazing and did all of the things themselves, but are actually wrong. Right? So imposter syndrome is when you're actually pretty good at something, but you don't believe it. And Dunning-Kruger is the opposite of that. It's where you believe you're very, very good and you're not. And so I think imposter syndrome is okay and it's healthy. And I don't think that we'll ever get beyond that, because everybody presents their best world, right? I mean, I was going to transition into, the research papers that you've published. You've got quite a prolific publication history, and some of the people in the chat have actually commented on that as well. And it's just interesting to see if people look across the landscape. I'm sure they look at your work and go, she's amazing, unbelievable, all the work that she's done, all the things she's contributed to, and you sit back and say, I wish I'd done more.
Yeah,
right?
That's a different feeling. It's kind of a self-appreciation. But I am very glad I have all those mentors. They are super, super supportive. And some of the people you even talk to, whether in this program, Julia Hirschberg or Dilek Tour, and they were supportive of all of my career development in the past. And Yeah,
Right. None of us got here
appreciate.
by ourselves, right? That's what I always say.
Yes, yeah,
We're-
definitely. So I'm also saying whether we should all pay it forward, and I'm also doing things I can to help whether the next
right.
everyone.
So speaking of papers, let's get into one specifically. I know you just had you're one of the authors accepted for a paper in InterSpeech, and I'll let you talk about it. But it's leveraging ASR for deep entity retrieval. Can you tell us about that?
Yeah, so this is related to both speech recognition and the downstream processing. So this is an entity retrieval task, and I know many people use some sort of assistance, whether it's Siri, Alexa, Google. Often the time, if there's an entity in that user utterance, it may not be correctly recognized, especially if it's a rare entity. You are trying to search for a local restaurant, and these assistants haven't heard of it. You're checking weather for some city, but not very populated weather city. So if the entity is not correctly recognized, it's very hard for these assistants to take action because they need to look at the database or the catalog and see, oh, this is the one you're referring to, and I'm going to take some action, whether it's returning the information about that restaurant or play the music or the song whether the user is asking. So what do we do when that entity is not correctly recognized? You cannot retrieve the correct entity. And in this particular paper, we look at it, can we use multiple recognition output? Because speech recognition system called ASR, it doesn't just return the one best hypothesis. It can also give you multiple candidates. This is a very old technique. Like I said, whether even when we worked on problems 10 or 20 years ago, everyone was looking at multiple candidates from ASR system. But here now we are in this deep learning era, and we were trying to use a new technique to look at the old problem. So we used all of these neural network methods and then explored different ways to represent n-best hypothesis from speech recognition system. And we use all these techniques called attention deep neural network to determine what is the best representation for those n-best hypotheses. And our results do show when you use multiple candidates from ASR, then you get much better results than just relying on the top one hypothesis.
Yeah, I think
so
that's probably
it's not
good, right?
surprising.
I mean, as you think about, no, that doesn't seem like it's surprising, but it is certainly interesting to think about that we're doing additional work that the user at the end of the day may never see. But we're saying, hey, they said this, but it could be one of these 5 best things, and then we work through that process using natural language understanding and a number of other tools to kind of understand what is the actual best out of these.
Right. Yeah. So this is a problem that's very typical for these kind of pipeline system. You have speech recognition, you have some understanding components afterwards, and if the first components doesn't provide the right hypothesis or prediction, the second one is going to suffer, and the error is going to propagate to the next component. What do? And you can ask the upstream of that component for more information, and then you do your resolution retrieval, any kind of understanding in this subsequent components, and you will do a better job because you have other information available like catalog, even some user related information.
Got it.
And then related to this problem, we're talking about how ASR errors may affect some downstream understanding task. And if I may, I just want to advertise what something we are also doing. So our team, especially with a scientist, So-Kwang Kim, he's the main driver. For this challenge we are organizing, this is one of the tracks in this year's Dialogue System Technology Challenge, DSTC Challenge. We are trying to evaluate all of the conversation modeling or the dialogue system performance using speech interactions. A lot of the research on dialogue recently has focused on text-based conversations. And we know when you use dialogue systems, often it is speech-based interaction, and speech recognition errors have a negative impact there. So we want to see whether in real scenarios, what is the performance of all of these dialogue systems or conversation modeling technology. And we're organizing this DSTC challenge, and I hope there will be many participating system, and then we can see what how we can advance the technology.
Yeah, that's excellent. I actually just shared a link to that directly with our audience, so hopefully we'll have a few people check out that challenge. That's very, very interesting. Speaking of papers, another topic that you've been covering lately is common sense inference for smooth and effective communication. Can you help me understand kind of what that means?
Yeah, it's a very hard problem. So we were just talking about some very specific task-oriented conversation, right? You want to check the weather, you want to play some music, and that's all task-oriented conversation. This common sense related work is for open domain conversation. So this is like for chatbot, social bot. Recently, this is very big. There are a lot of research papers in the science community, and you probably have seen some announcement from different companies. Google has a chatbot called Mina, Facebook has one called BlenderBot, and Baidu has one called Plato. Everyone is investing in this area using all these large pre-trained models to build the open domain conversation or dialogue systems. But the technology is not ready yet. And there are a lot of problems in these neural generation approaches. The system may not be consistent with itself. It says something in one turn, and in the next turn, and you'll see a contradiction there. It may repeat the information it has just said in the previous turn. It may give you something that's not factually correct. And you were talking about empathy. The system doesn't show whether the correct empathy when you are sad, and it still says, oh, blah, blah, it's very excited tone. So to address these problems in the research community, often the time people, because we're using all these machine learning models, so they start trying to get appropriate data to train models to address those specific problems I mentioned, whether it's factual correctness or empathy or consistency problem. But there's one aspect that hasn't been studied a bit for this open domain conversation, that is common sense. So I can give you an example. If I tell my friend, oh, I'm going to have a live interview tomorrow with Jeff in this Alexa and the Friends thing, his or her reaction may be, but don't worry, you will do very well, because the person probably knows I'm going to get nervous because it's a live event. So this kind of implicit common sense reasoning is not very well modeled in the current neural network based approach, and that's what we were trying to do. So how do we do this?
It's very interesting to approach that, because we call it common sense, as if all humans should just know that this is something that's natural and obvious.
Yeah. That's why it's called common sense. And these things are implicit. It doesn't say, oh, I think you're nervous, and I'm going to say, oh, don't worry, then you will do just well. How do we get that implicit part? And how can we get appropriate data sets or corpora to train all these models? So that's how we would started. And we thought, oh, we need a data set to do this kind of thing. Where do we get this kind of social related reactions or conversation or dialogues? So we started with something called social IQA. And from the name, you may be able to tell it's related to social events. That's a data set collected by some folks at Allen AI and other places. I can give you a scenario or example in that data set. Example says, Alex or Jeff spilled spaghetti or food on the floor. What is this person going to do? And there are multiple choices there. This person is going to mop up or clean the floor, and this person is going to eat the food. This person is going to run around and play in the mess. So we want to see whether when this data set was developed, it's meant to see if machines can do this kind of common sense reasoning, handle some social events. And we thought, oh, that seems a good starting point for us to collect the related conversation or dialogue. So we use those scenarios or context in social IQA data set, and we asked the crowd workers to write a conversation about that. Oh, I spilled the food. And then your friends may say, oh, let's clean it up. Your friends may say, oh, no food, and let's order pizza. So these are all like natural reaction, and they kind of capture this kind of common sense whether we're talking about. And we collected this data set, and right now it's in the final processing. We do want to release to the entire research community. It should be out pretty soon. And in that paper, we look at it. using these neural methods trained using the data set we collected and also some other existing data sets, and we showed what good performance when you use these more like a common sense related conversation or dialogue. Yeah.
Very cool. So our audience has already mentioned one of these, but the question I want to ask you next is about the hard challenges. What are the really big problems that you're facing as you get into this? And so in the dialogue system space, what are the big problems? The one that was mentioned in the chat was the idea of sarcasm. I know that that's a very big challenge in
that is.
But when you think about your big challenges that you face, what are the things that stand out to you?
Yeah, so it's not one challenge. I do want to mention multiple challenges. And in those two papers, we talk about the two different kinds of conversational dialogue system. One is task-oriented one. We know right now all these assistants, they do pretty well for a very specific task, play music, check weather, or even multi-turn conversation. If you need to make a hotel restaurant reservation with a few turns, the system can get the information they need and they can complete that transaction or finish the task. But that's all what the current system can do. The conversation is quite rigid. You cannot go with all that predefined schema or intent and entity or slots. So how do we scale up to different scales, to different tasks? How can we allow users to say things in a more natural way, rather than just completing or providing the agents with the information the agent is asking? How can we train models using less data? We don't want to collect the hundreds of or even thousands, millions of utterances for each of those tasks we are doing. These are all challenges for that task-oriented conversation. And then the other side of that spectrum is the one we were just talking about, this open domain conversation. If you want to have a chatbot that can talk to you about pretty much any topic, there's no way you can write these predefined prompts or responses for each of those topics, right? We cannot even list all of the possible topics. So all of these neural network-based approaches, they are very promising. You don't have this constraint, you're only covering certain number of topics. But as I was saying, the current technology is still far, far away from human performance, from getting a good reaction from the users.
Yeah, I think that makes sense. That sounds a lot like what we're going to talk about next, which is the Alexa Prize. I mean, that contest is kind of tailored around that open domain idea, right? Where
indeed, yeah,
the competitors, who I think the most recent winner was the Czech Technical
University. Yeah, they just announced the winner.
But so I would imagine you probably have more to share on that. But I'd love your perspective on the Alexa Prize and the competition and kind of the goals that are out there to do that.
Okay, that's good. Just in case whether people don't know about this Alexa Prize, one of the kind of tracks in the Alexa Prize is the SocialBot Grand Challenge. This started a few years back. I think it's 2016. Amazon or Alexa started this competition with the goal to help advance the field of conversation AI. And then the task is for the university teams to build these so-called social bots or chatbots that interact with the real Alexa customers. If you have a device at chat, then you will be talking to these social bots developed by university teams. The ultimate goal for this Alexa Prize social bot competition is to get a score of 4 out of 5 from judges. When you have these open domain conversations, at the end, you can read how did the conversation go, and then you give a kind of a subjective score. And in terms of the length, the goal is also to have a conversation with a minimum 20 minutes. This is very hard. And as I was telling you right now, all of the approaches we use, you see all those repetition, contradiction, incorrectness, all these things. So if you have a 20 minutes conversation, you're going to see all those problems. It's very hard to have a 4 or 5 with a score out of 5 if you have a long conversation. So we haven't... we haven't met that goal yet, and this is the end of the 4th competition.
Sorry, you and I
Go
have been
ahead.
talking for almost 40 minutes. I wonder what the judges
Oh.
would think of this 40-minute conversation.
I think it's very natural, and because with what we were just doing, this kind of turn taking, back channel, and then interruption, we still handled it very well, right? You were trying to say something, and I will see if I should yield the floor and let you talk. In the current what about that's very hard. Yeah, but there are other problems. So I was just saying we haven't met that goal yet. And this year's competition, this is the end of the 4th year. Check with university was the first place, followed by Stanford University and University of Buffalo. After 4 years, many university teams would attempt, and we haven't met that goal, and that tells you this is indeed a very challenging problems. But we also see a lot of good progress from these university teams in the past years. They have been increasing the coverage of the topics the system can have a conversation with the university about. The conversations are getting more and more engaging. And especially this year, a lot of the university teams are exploring the neural network web-based approaches for generation. So they don't need to write all of those rule-based or template-based responses for different domains. So I'm hoping to see what a more advanced one from all these teams.
But I think that's how we grow, right? We have to do a lot of it manually first, and then we look at ways to kind of consolidate and grow those manual processes into machine learning operations. I think that's it's natural to try to progress that way. And this is it's interesting to see that we're starting to pivot and turn towards a more neural approach.
And the good thing for these competition is these university teams or the social bots, they are using Alexa customers, so they get the real data. This is very different from the research they do in the university lab setting. Oh, I'm going to recruit 10 or 20 people, or maybe a crowd worker, 100 people, and try the system I'm developing. So every day they get a lot of real conversations. And at the end, they get the ratings from real users, and they also get some verbal feedback about the conversation. That's very useful for the university teams to improve or continue to develop their systems.
Agreed.
This is a very good opportunity Amazon provided to the university.
Yes. For any of you that want to try this, if you're not aware, you can talk to any Alexa device that you own. And I won't say the name, but you can say, "Let's chat."
Yes.
And that will randomly choose a chatbot for you, and you can try to have some of those conversations with these university projects. It's a really fun way to try and have a long conversation with an AI.
Yeah, and there's also a new competition that has just started this year. So I was saying that's the track 1 in Alexa Prize. The new competition is a task bot. This is different from the open domain conversation. The task bot is meant to help customers to finish some task, and we're looking at 2 tasks. One is the home improvement, the DIY. I know a lot of people are probably interested in that. And the other one is cooking. If you want to bake a cake, and then you can ask Alexa to help you with those different steps. So this is the other competition. And right now, 10 university teams are participating in this competition. And I remember the task bots will be available to the customers later this year. I don't remember the exact date. Yeah, so it'll be very interesting to see this new competition. This is a multimodal one, not like the first one. You have an Echo Show device, and you will see whether an image or video that tells you the steps you need to do for the DIY or cooking.
That's exciting. Very cool. All right, we're going to get back to more papers you've written, because you've written so many. But one of the things I'd like to ask about is a paper you recently co-authored about the growing popularity of virtual assistants. And one of the things that's near and dear to me as an Alexa skill builder is the idea of entity resolution. So can you go into more detail about what that paper entailed?
Yeah, I can briefly mention it. So this is what a recent paper is. You said it's about entity resolution, and this is for Alexa shopping application. When you talk to Alexa, you can say, add milk to my shopping cart. What does milk mean when you say milk? You probably are thinking about a particular brand or that milk maybe you ordered last week. So we need to resolve that entity. We need to find a ranked list of the relevant entities. How do we do that? We have users history information we can use based on the products you have already purchased. We also have descriptions for different products, the attributes for the products. So we look at all these kinds of information. Again, we use deep learning graph representation to kind of merge these things together to find a good ranked list of relevant product users. That's a short description.
Very cool. No, I think those are the kinds of things that we just take for granted, right? Because in the example you used, add milk to my cart, milk can mean a lot of things. Do I mean almond milk? Do I mean normal milk? Do
organic
I mean
milk, a different particular brand, anything? Yes. Yeah. So people do all these things, and everything is kind of implicit. I didn't mention what earlier when we were talking about the common sense reasoning. In that conference where we present the paper, there's another paper. They are also doing things similar. So example in that paper is, oh, the view is so pretty, and then the expectation is the assistant is going to ask you, do you want me to turn the camera app on? So user may say things in a very implicit way, but hoping the smart, intelligent assistant is going to take the right action, figuring out that transaction. We do need to use a lot of rich information to do this, like the milk example. I can have a collection of all of the milk, and for every milk, I have the description there. I can also find similar customers to you, and then find some similar ingredients, similar shared common things between the products you have, and the relevant do this kind of reasoning.
I have to say, one of my favorite parts about having these conversations is getting a view into the future that you see, right? Because as you work on your research, you know what is eventually possible, although it's not necessarily possible today.
Yeah.
You have these big dreams, these big ideas that are in your head about how things should work and how they will go. And oftentimes they're just patterned off of what we see with natural human interactions or whatever. But that is one of my favorite parts about having these kinds of interviews, is that I get to see inside your head a little and understand just the nuance of being able to sit and see a beautiful mountain range, and just by saying something, you just imagine that your camera will turn on and record some of that for you or take a picture. I absolutely love that.
Yeah, I think whether the product manager or those PMs can collect the more requests, whether from the users, and Alexa, and then we can do these working backwards from the user's needs or request, and then we'll see how we can close that gap and work out the technology for it.
Yeah. So we've talked a lot about your career and certainly a lot of the work that you've done recently. Is there something that stands out to you as kind of your biggest accomplishment in your career so far?
That's an easy question. That's a short answer. I think whether like as a parent, and the most what the thing you are proud of is probably some achievement from your children. I don't know if that's how you feel. So looking back on my career, I think what the most rewarding thing is seeing some achievements from the people I have mentored, like knowing some achievement from former students, postdoc, or maybe people I mentor, whether in the company. Yeah, there's no doubt about that. I still get messages or emails from people I have worked with or former students, and they tell me, oh, I get promoted, I just became associate professor, or I'm invited to give a keynote talk in this conference. I think that's the most rewarding moment.
I would agree with you. I think that's often overlooked, though. I think a lot of people view being someone that offers mentoring as oh, that's extra work, or I don't want to do that stuff. But the reward that you get on the other side, seeing people successful because they took your guidance, your advice, because that's we often say at Amazon, trying to find a way to scale through others, and it's interesting to me to think about that perspective, that if you go off and do your work in a vacuum by yourself, your capacity is limited. But if you spread that knowledge and spread that experience across a number of people that are coming up, now your work is not only taking place in front of you, but in front of dozens of other people as well. So that's a great response to that question.
Yeah, that will be a better world.
Yeah, I agree. All right, so I also noticed in your bio that it lists the Air Force Young Investigator Program and the NSF Career Award. I'd love to know about this Air Force Young Investigator Program. This sounds interesting.
Yeah, so these defense agencies, including Air Force, Army, Navy, Department of Defense, they all have this Young Investigator Program, YIP, award. And the program is meant to support people who are in their early career development. Typically, the rule is it's 5 years after you get your PhD, and then you are qualified for this award. And the goal is to, of course, help these early career development of these whatever outstanding investigators or scientists. And they also tries to increase the opportunity for these scientists to recognize or understand the needs from these agencies, the research problems they care about. Of course, there's another fundamental objective to just support the basic research in all kinds of areas in science and technology. And I think every year, at least for Air Force, typically 30 to 40-ish scientists are selected every year for this YIP award. So I got the award 2009, 2010, yeah, a long time ago. But my funded research from Air Force was about emotion recognition in speech. So when we're saying things, and I want to know whether you are happy, sad, angry. And there's a notion in the community, and you probably will agree with me, there is some universal aspect. Even if you don't know the language, you probably can roughly tell this person is angry, sad, happy. And there's also some culture-specific part. So we want to look at this from both cross-culture and also universal weather thing, and see if we can build a cross-lingual emotion recognition systems. So the first paper we did for that funded research is looking at the cross-lingual emotion recognition in both automatic systems as well as human perception. And we recruited people who were native Chinese speakers and native English speakers, and we played Chinese, English, and German different speech with different emotions, and we were looking at how people perceive these emotional speech in their native language and also in the language they don't know. And of course, we also did the automatic part, and we trained the system using one language, and we evaluate the system using the other language. And of course, this all happened before the deep learning got so prevalent. It was using the old classification approach, like support vector machines, those kinds of things. But the general message is probably still applicable right now. If you look at all these automatic systems, they suffer quite a bit. If you train the system using one language and you evaluate the system on the other language, you see a lot of degradation. But if you look at a human perception, there's a little bit degradation, but not a whole lot. We can still get some universal cues about the emotion. I'm thinking another finding not from us is between the visual cues and the speech, there's more universal ones from the video one. Like if you watch a movie or a video speaking in another language, I don't know what languages you speak of, but maybe what imagine is Chinese. Just looking at the characters with the facial expression and listening to their speech, you probably can get the character is happy, angry. But I think most of the information comes from the video one. The speech, you probably can tell when people shout, and there may be
for sure,
maybe a good indicator.
Has there been any research done about, are there any specific languages or cultures that don't map well to that? Like, we talk about like the sound of anger is pretty universal across languages, but are there places or dialects or languages where that is not true?
I don't know the answer to that question. Yeah,
it was just
based on the literature we did back then, but those probably were all the languages that were widely studied in the research community. This is also related to the low resource language problem. Maybe there are things out there that we don't quite know. Yeah, so I don't have a lot of information about those kinds of languages. Yeah, that's a good question.
It was a curiosity question.
Yeah, definitely.
I think that it would be odd if we found like a small tribe someplace that
Definitely.
their anger
Yeah.
sounded like laughter or something.
Yeah.
But probably unlikely. And honestly, as our globe continues to get smaller and smaller, and we get exposed to more and more other cultures, just through television, radio, internet, I think that we will find more and more
it's
similar.
very different.
As we
And
were.
maybe going back to that superpower, what I had, if people can express the things in the right way to the audience, and then we'll have no miscommunication at all, even though you are using a weird original or the intentional language.
All right. We are almost out of time. I have one more question for you before we wrap up here. I know that a lot of the folks that are in our audience might still be in school or are pursuing a lot of the careers that we've been talking about, some of their research and industries. And so I'd really be curious, do you have any advice for people that are looking for careers in speech or natural language processing?
I sort of do. I'm not good at giving what advice, but as you said, since I have these years of experiences, I do have some tips. So first, I want to say if you are interested in all these, speech, language, technology, you are in a very good time right now, and this is a growing field, and there are a lot of interesting problems out there, and some challenges we mentioned earlier. And you have data, and you have computing resources, and there are also a lot of tools, open source stuff out there. So it's very easy to get into the field. But then once you start, that's what I meant. I do have a few tips. So in terms of the technical part, I think it's good for everyone to build a very good foundation. So this requires the breadth and depth of your knowledge. And if we can use the technology we talked about previously, so just take speech or language as an example. We were using something called the hidden Markov model, HMM, for speech recognition. And then that technique was adopted in many other natural language problems, in in machine translation, in part-of-speech tagging. Another example is this thing called the convolutional neural network. It was developed in computer vision, but then it was also adopted in natural language processing for text classification to find what a sentiment, to find the topic of different articles. So these are just examples. If you know more and you also get inspired from similar or other fields, this requires quite some breadth of the knowledge. And then for the depth part, you really need to have a good understanding for that particular problem you are working on. You don't want to just report, I'm getting 10% better accuracy than some previously published papers or results. You need to ask yourself a few questions. Why? What findings you are getting? What do the results mean? What are the contributions from different components? So this requires some deep understanding. And in Amazon, we have a leadership principle called dive deep. This is what every scientist or every person who's working on these scientific problems needs to have. And of course, the rest is all about the general problem-solving skill. In universities or maybe in your lab setting, some people have already formulated the problem for you. You have a data set, and you just need to develop some models to try to get a better performance. But in real world, you need to formulate that problem yourself. Maybe you need to collect your data. You need to define your metric. So it requires a lot of these problem-solving skill. And then what else is important? Soft skills, collaborating with other people, having open-minded, have a good network. All these things are extremely important. So I think I've touched on technical already.
It's funny how often we have to tell people, and I mean we just in the global that working with and collaborating with people is something that you need to be good at. Because I see so many people that just want to live in their own box and do their own thing. And the growth and the knowledge and the big leaps in anything came from people working together. Mine goes off sometimes too. It's quite all right.
Yeah, maybe that's why I mentioned what are those ducks or horses. They're going to collaborate. That's the first the reaction. When you have a team, and then you need to work very well with the others.
Agreed. I heard depth, I heard problem solving, and I heard collaboration. I think those are all positive strengths for anybody that's thinking about getting into both science or technology at all. All right. Well, Yang, I want to thank you so much for being here today. For all of you that are watching, if you want to see any of the papers that we've been discussing or anything, you can go to Amazon.science to check out her research as well as everyone else's in our Amazon Science organization there. There's also InterSpeech 2021 page, and you can find all of the research papers from this year's conference there. I really, really appreciate the fact that you're willing to take the time to share your knowledge and experience with all of us. It goes a long way, and based on the conversations I'm seeing in the chat, you've certainly inspired some people to take the next steps in what they're thinking about too. So thank you so much for being here.
Thank you for having me.
Certainly. All right, I'm going to leave all of you with a short video all about working in the Amazon Science Organization. But thank you guys all for tuning in. This is the end of the stream, and we will see you all again next time.
My name is Olabanji Shonibare. I am an applied scientist at Amazon. I work with the Paralanguage Understanding Service and Response team within Alexa Speech.
My name is Aparna, and I'm a senior applied scientist in the Alexa Speech Recognition team. Currently, I'm working on building better experiences for bilingual customers of Alexa, just like myself.
My name is Venki. I'm an applied science manager in Alexa AI. Me and my team of scientists work on different paralinguistic signals associated with voice. As we know, Alexa is used by many customers across languages, across age groups, with different types of voices. We make sure we understand everyone irrespective of their variance in their voice.
Hey there, I'm Jaime Lorenzo. I'm an applied science manager in the Alexa text-to-speech research team. I joined the team 3 years ago with a task to improve the expressivity and naturalness of our synthetic voices, and this resulted in the release of the emotional capabilities for Alexa. Currently, I am working with many other teams trying to push forward the envelope of what we can do with our technology.
I'm Kayoko. I'm a senior speech scientist in the text-to-speech team at Amazon. I joined Amazon 5 years ago and initially worked on the launch of Amazon's first Japanese text-to-speech voice in the Polly service, followed by the launch of the Japanese Alexa. And more recently, I've worked on the launch of bilingual Alexa, making the American English Alexa voice speak Spanish.
Buenos días, mi gente.
I get to work on problems that are not well defined. You will be expected to develop and deliver end-to-end solutions. You would work on problems that are unstructured. And then, depending on the level, you might be expected to mentor a junior colleague as well.
One of the things that anyone will notice when they work in Alexa AI is the amazing group of scientists and engineers that we have around here. So there's lots to learn. Over the last 2 years, I've learned quite a bit. It's helped me become a better scientist, a better thinker, and a better employee.
We are constantly learning new things, so we are having to adapt and adopt new technologies. Not only that, we are keeping learning, we are keeping absorbing technologies from other fields such as NLP or computer vision. There is always a chance to keep learning new things, so I'm never bored.
Many of the problems that I worked on did not have any prior research work on it, or very little of it. There are also problems on which there's plenty of research available, but many a times the work done on academic data sets doesn't really translate when we work on solving these problems for Alexa customers. I really enjoy the challenge of working on and solving these problems, and this is really what makes innovation at the heart of what we do at Alexa.
Nowadays, more and more machine learning techniques are being applied across different domains, and in text-to-speech, we're using a lot of approaches developed outside of the speech domain, which means that we see a lot of researchers with completely different backgrounds joining us in TTS.
The customers, they are placed at the forefront of every decision we make. And so if there's any character or skill you think that would enable you to be customer obsessed, that's a +1.
Alexa is a fantastic place for anyone who wants to work on solving real-world practical problems with deep learning in the speech and natural language understanding space. There's plenty of opportunity to innovate and build state-of-the-art solutions for some of these problems.